Hi all, today I am going to present our paper that is SPC to 3D, that is novel view synthesis from binary SPC via image to image translation. The authors of this paper are Sumit Sharma, Gopi Raju Matta and Dr. Kaushik Mitra. We are from Indian Institute of Technology Madras, India, and we are going to present our paper at ICIP 2025. So first of all, we should know about single photon camera. Single photon camera are the novel cameras and they are based on single photon avalanche diode sensors. In single photon avalanche diode sensor, when a photon arrives at the sensor, then then it triggers multiple electrons. That is, the avalanche breakdown happened at the sensor. But whereas in case of CMOS sensor, when a single photon arrives, then there will be one electron correspond to that photon knocks out. So it means the sensitivity of SPAD sensors for a single photon are much higher as compared to the CMOS sensor. This makes it ideal for many applications like low light imaging and also extreme high dynamic range imaging. As we can see, but there are some drawbacks in the single photon camera images or single photon camera, like the images are too much noisy because they are binary. Also, there is not any color information in it. But in case of CMOS sensor, the images are perceptually better as compared to the SPAD based sensor. Also, there in SPC based sensors, there is a soft saturation limit, as when it means that aspect sensor can able to capture large amount of information or highlight information as compared to the CMOS sensor, whereas it is since it is having a hard saturation limit. Because of these characteristics, aspect sensors are 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 a better choice or are a good choice enough for recording extreme high dynamic range imaging. So what is the motivation for moving from single photon camera images to 3D color novel views? Since there are hardly any methods which claims to move from single photon camera image or binary image directly to color novel views. So there are very less methods which claims that. So like in this particular method in this slide, which comes from quantum burst photography paper, we can see that there is a burst of binary images, and from the burst of binary images, the algorithm moves towards the high quality, low blur, low noise, high dynamic range image. So this particular algorithm not talking about 3D novel views or 3D color views from the binary images. So there are so many applications from the SPC captured image or binary image. Like we can we can detect the pose, we can detect the object, we can detect the face, we can detect the motion, we can we can scan the QR code in low light environment, we can record the low light images. So there are so many applications corresponding to the single photon camera captured images. So that's why we are moving towards novel view synthesis from binary SPC. So the overview of our method is, since we are moving from a 3-channel simulated single photon camera image to color novel view, we are break this particular process into two parts. First is the image to image translation part, and other one is from 3D novel view synthesis. For image to image translation, we used we used different algorithms or different networks like pix to pix HD, pix to pix, cycle GAN, look at me, and also we tried to denoise the single photon camera images or binary images, and then from that we try to move towards the color novel view. So first we just have a brief intro about image to image translation network. So in image to image translation network, we are moving from one particular image to other particular image. There are many popular image to image translation based methods. One of them Three of them are pitch to pix, cycle gain, pitch to pix HD. So pitch to pix is very old method. From pitch to pix, the upgraded version is pitch to pix HD by NVIDIA, which generate high resolution images. And this pitch to pix and pitch to pix HD are the supervised training based networks, but cycle GAN is unsupervised based network. So in for the 3D reconstruction, we mainly focus on the neural radiance field and 3D Gaussian splatting. So the neural radiance field based on the multi-layer perceptron based network, where we are giving the x, y, z, theta and phi as the input, where x, y, z are the coordinates, theta is the vertical orientation, phi is the horizontal orientation or horizontal angle, and then from that there is a mapping towards the RGB image, towards the RGB color with density. So we are sampling the views from different direction, and finally we try to get the novel views. Whereas in case of Gaussian splatting, we are moving from the cloud points towards the 3D Gaussians, and then from 3D Gaussians we are moving towards the novel view synthesis. So single photon camera simulator. So we prepared the single photon camera simulator in our lab, where we are moving from the input RGB image to a 3-channel binary image. So this 3-channel binary image we simulated channel wise. So channel wise we are simulating the binary image based on mean, this particular mentioned mean and variance, where this mean and variance depends on certain factors like QS pad, which is the sensitivity of the sensor, phi, that is the input flux, T, that is the exposure time. So that QS pad varies from 0.45 to 0.75. Phi is the input image, that is the RGB image. T is the exposure time, which depends on the luminance of the image, and tau d is the dead time. So here we are assuming that the single photon camera act in a passive mode, not in an active mode. That is without any external light source. So these are some qualitative analysis which I am going to show. So here we can see that the left column is the SPC input. Then we have the SPC. We applied Gaussian splatting over that. So this is the Gaussian splatting result over SPC images. So we can see that it is light in colors, means it's not able to faithfully reconstruct the images. Whereas we also applied the Restormer and then on the SPC images and then Gaussian splatting. This is the particular results, and then pitch to pix HD followed by Gaussian splatting. So here we can see that the texture information are much better as compared to the previous attempt, and but still the color is not exactly matching to the particular ground truth images. So this is the neural radiance field outputs. So here on the first particular column, we can see that pitch to pix followed by nerve. So the particular images are not at all good. They are much distorted. Then we experimented with Restormer followed by nerve. Images are light and light in color. Here then we applied nerve directly over the SPC images. These are the particular results. Then we also applied diffusion based denoising over the SPC image and then nerve. The colors are sharp enough, and here the last particular column is the pix to pix HD plus nerve. So these results are also much better as compared to the previous attempts in terms of texture, in terms of color also. So this is the particular quantitative result. So in the quantitative result, we can say that pitch to pix HD plus nerve combination is better in terms of PSNR, SSIM and LPs. So PSNR we can see, since we are moving from the binary image to a color novel view. So this we are getting much better PSNR as compared to the previous methods. So pitch to pix HD plus nerve or 3D with the other possible combinations. Whereas we also did the ablation study with direct nerve and 3D and our two-stage approaches. In that also, we are getting much better PSNR, we are getting much better metrics as compared to the nerve or 3D. So the conclusion is, in this paper, we presented a modular two-stage framework that transforms the binary SPC image into color novel views. By integrating the pix-to-pix HD for image translation with NURF or Gaussian splatting for 3D reconstruction, our method demonstrates notable improvements in terms of texture, perceptual quality over other combinations. The use of the feature matching loss, which is the specialty in pix-to-pix HD as compared to the pix-to-pix, the particular it contributes to enhanced synthesis quality. While the current architecture builds on existing components, its application to the challenging domain of binary SPC imagery highlights its practical relevance, that how much it is practical with the binary images capture. For the future work, we are right now working on a single stage architecture which can take directly the 3-channel binary image and gives the color novel views. Thank you so much.